Namaste. Good afternoon. Today we are taking up or learning the topic change of axis. Change of axis. Let me see how many of you are online. Arun, good afternoon. Samegar, good afternoon. Okay. Now the change of axis. Yesterday at the end of the topic, end of my session yesterday, I discussed the purpose of change of axis. Let me repeat that. When there are fixed axes, one original axis, x-axis, y-axis, what is the purpose? What is the use? What for it is useful to shift the origin? This is the origin here. To shift the origin or to rotate the axis. What is the purpose of it? What is the purpose of it? Mainly the shifting of origin or rotation of axis is useful to reduce the bigger equations to the smaller form. What are the bigger equations in two-dimensional geometry? What is the maximum size of an algebraic equation in two-dimensional geometry? I told you that already. I taught you that already. It consists of 6 terms, and I asked you to remember that also. That is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. I said this is the maximum size of any geometrical figure equation in two-dimensional geometry. So how many terms it is consisting? It is consisting of 6 terms. 1, 2, 3, 4, 5, 6 terms it is consisting of. So I gave you in locus the different conditions for this equation to represent different geometrical figures. What are they? You might be remembering. If it is to represent a straight line, your A, H, B must be 0. A, H, B must be 0. Then what are the terms remaining? X, Y, and constant terms are remaining. In these two also, at least one of G and F must be non-zero. Then only it represents a straight line. If it is to represent a pair of lines, then what is the condition? I gave you delta also. Delta. We name it as delta. What is the delta there? Delta is nothing but a handsome guy has beautiful fiancée gone for cinema. A handsome guy has beautiful fiancée gone for cinema, and if you find out the determinant of it, ABC plus 2FGH minus AF square minus BG square minus CH square. This must be 0 there to represent the second degree non-homogeneous equation. Second degree 2, 1 plus 1, 2, 2. This part is said to be homogeneous part. And it is power 1. And its power, there is no variable here, its power is 0, and hence 0, 1, 2. Powers are unequal, and hence it is said to be non-homogeneous equation. If you take only these three terms, it is said to be second degree homogeneous equation. The second degree non-homogeneous equation to represent a pair of lines, this must be 0. And h square is greater than or equal to AB, g square is greater than or equal to AC, and f square must be greater than or equal to BC. There are 4 conditions for this second degree non-homogeneous equation to represent a pair of lines. If any one of these conditions fail, then we say it will not be representing the pair of lines, but it will represent any other geometrical figure. Any other geometrical figure. So what are the other geometrical figures? We have taken the standard figures. Next we have taken a circle. For a circle, A is equal to B is equal to 1, or A must be equal to B, and H must be 0. H must be 0. This equation represents a circle. This equation represents a, and of course delta is always not equal to 0 for rest all geometrical figures except for pair of lines. And delta is 0. Delta is 0 only for pair of lines. Delta not equal to 0 for a circle, delta not equal to 0 for a parabola, delta not equal to 0 for an ellipse, delta not equal to 0 for a hyperbola. For all these, delta is not equal to 0. And if it is to represent a parabola, if it is to represent a parabola, your h square is equal to AB, your h square equal to AB. And if it is to represent an ellipse, your h square must be less than AB. That is a unique condition for ellipse. I discussed that also. There is no clash with any other condition for the ellipse. H square is less than AB. H square is less than AB. Similarly, it is to represent a hyperbola. It is to represent a hyperbola. Karthik, good afternoon. It is to represent a hyperbola. Your h square must be greater than AB. Your h square must be greater than AB. All these are the different conditions. And the importance of this second degree non-homogeneous equation is that any geometrical figure in two-dimensional geometry is denoted by a second degree non-homogeneous equation under certain conditions. Under certain conditions. This is to be understood. Now, let us understand the change of axis. What is the purpose? Purpose is to reduce the bigger equations of this type to smaller one. We will eliminate some terms and we express the bigger equation to the smaller form. So let us see how to convert it to the smaller form. Number 1 is shifting of origin. Number 1 is shifting of origin. So shifting of origin goes like this. These are the standard coordinate axis or original coordinate axis, denoted by small x or small y. And now we are shifting this origin 0, 0 to some other point, without rotating the axis. We named them as capital X, capital Y. And what is this new origin here? Let me say this as some O dash. This is rho, this is O dash. New origin, I named it as O dash. This O dash, we will be taking it as x1, y1. So, what is the context here? The origin is shifted to a new point x1, y1. Now, what is that we have to understand? When all the points on the plane are denoted with the help of x-axis, y-axis and their point of intersection 0, 0, then don't you think that every point on the plane will also be shifted or transformed if the origin is shifted to some other point? Yes or no? What I mean to say? A point is there. Let me say this point as P. Now, if this point B is with respect to the original axis, 0, 0. Now, what I did, I have shifted this origin to O dash. I have shifted this origin to O dash. Then what happens? Obviously, this point P will also be shifted. Accept that first. Whether the points on the plane are shifted or not by shifting the origin. Yes, every point on the plane will be shifted if the origin is shifted. And thereby what happens? Every equation that are expressed in terms of x and y will also be shifted. So when the points are shifting, all the geometrical figures are made up of points only. When the point is transformed or when the point is shifted, then obviously equation will also be transformed. This is what you have to understand. But now, what we are doing? Let me say this point, particular point P, has coordinates small x, small y, with respect to the original axis. Has the coordinates small x, small y with respect to the original coordinates. Now, after shifting the origin, whatever the point is there with respect to new axis, whatever the point is there in place of P with respect to new axis, I am naming it as capital X, capital Y. That means Pxy is with respect to original axis. We shifted the origin to some other point O dash, and thereby whatever the point is there after shifting, of course P will be shifted somewhere, but we are not worried about that. We are taking that point which is there after shifting as capital X, capital Y. That means small x, small y is the original point and capital X, capital Y is the new point and x1, y1 is the new origin. Now we want to have the relation between small x, small y, capital X, capital Y and x1, y1. Okay, we are doing that now. Now let me drop a perpendicular. From O dash. Let it be some Q. Let me drop another perpendicular from P. Onto the new axis and original axis. Let me name this as P, Q, R, S. Just understand. This is the perpendicular. Understand that, please. What is that I did? I have drawn a perpendicular from O dash to original axis, small x, denoted by small x, and I have drawn one more perpendicular from P onto original axis and new axis. I named them. Now, our interest is to find out the relation between original point, new point, and new origin. So let me write down. This is OR. OR is equal to OQ plus QR. Now, do you understand what is OQ? I cannot hear your voice. I can see only your chat. That's the reason why. Even if you respond also, I cannot listen to you. So it is OQ. I'm interested in OQ. What is OQ? This OQ is nothing but x1, please. This OQ is nothing but x1. Now, I want QR. QR is nothing but O dash S. x1 plus O dash S. What is O dash S, please? With respect to the new axis, O dash S, with respect to new axis, it is nothing but capital X. So, what is OR, please? It is nothing but totally on original axis. OR is nothing but small x. small x is equal to x1 plus O dash S is nothing but capital X. So you got a relation now. You got a relation. Small x is equal to capital X plus x1. Small x is equal to capital X plus x1. Now let me take the y coordinate. Y coordinate is nothing but, come on, tell me that, PR. PR is nothing but, PR can be split as PS plus SR. What is PR? The entire length of it with respect to original axis is small y. What is PS, please? PS is nothing but capital Y. What is SR, please? It's nothing but O dash Q. What is O dash Q? Height of it? Y1. Got it. We got it. Small x is capital X plus x1, small y is capital Y plus y1. So what is the relation between these three? Small x, small y, capital X, capital Y, and x1, y1 is nothing but small x comma small y is equal to capital X plus x1 comma capital Y plus y. This is what the relation between these three, that is original point is equal to new point plus new horizon, to remember easily. What is OP there? Not outpatient unit. It is OP is original point. And what is NP there? It is not national permit, it is new point. We are learning mathematics here. What is NO there? Not known, new horizon. So original point is equal to new point plus new horizon. Original point is equal to new point plus new horizon. So this is to be remembered to work out any problem related to the shifting of horizon, please. This is to be remembered with respect to the shifting of horizon. What is that? Original point is equal to new point plus new horizon. New point plus new horizon. Now, what are the points that are to be noted in this case? If f of x comma y is equal to 0 is an equation, then transformed equation by shifting the horizon to x1 y1 is f of, in place of x, x plus x1, in place of y, y plus y1 is equal to 0. What is it? Transformed equation. What I mean to say here? If you have an equation f of x comma y equal to 0, if you have an equation of a geometrical figure f of x comma y equal to 0, then if you shift the horizon to some other point x1 y1, then the transformed equation of f of x comma y equal to 0. Transformed equation of f of x comma y is equal to 0 is nothing but f of x plus x1 comma y plus y1 is equal to 0. This is what you have to understand. That means if you shift the horizon, definitely every point on the plane will be shifted. When the points are shifting, because every geometrical figure is made up of points only, then the equation will also be shifted or transformed. The transformed equation is got with this one. Now, what are the formulae that are involved here? See here, carefully. Now, formulae for this one. Related to this. To remove first degree terms, rather x comma y terms, in ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. What is that you have to understand? To remove x comma y terms in, this is x term, this is y term, this is x term, this is y terms. To remove this, the origin is to be shifted to hf minus bg by ab minus h square comma gh minus af by ab minus h. Then you must be surprised, sir, how to remember this much a bigger formula. Yes, this is a bigger formula only, but you will get the same in pair of straight lines also again. The point of intersection of pair of straight lines is given by, if this represents a pair of straight lines, then the point of intersection of pair of straight lines is also given by this one. So if you remember that formula, that will be very good. If you are not in a position to remember the formula, then what is to be done? There is a short form to work out this. There is a short form to find out the new origin. What is this here? The origin is to be shifted to this point. That is nothing but, this is nothing but, you have to understand, nothing but the new origin. Sometimes what happens, A and B will not be there. When A and B are not there, this will be simplified. A and B are not there means A becomes 0, B becomes 0. Understand that? A becomes 0, B becomes 0. Thereby only xy term, x term, y term will be there. And what happens? Here you have to write B 0 and here AB becomes 0. So hf by minus h square becomes minus f by h. Minus f by h. Here also this becomes 0, gh by minus h square and minus g by h. Like that, the formula can be simplified. Whatever, that is a basic formula. Sometimes h becomes 0. H becomes 0 means what? You will not have xy term. When xy term is not there, this h becomes 0. This h becomes 0. This becomes 0. This becomes 0. Then what is that remaining? Minus bg by ab. bb getting cancelled. Minus g by a. Minus f by b. So what happens whenever any one of these terms are missing, this formula will be simplified. That's what you have to understand. This formula will be simplified. How it is simplified? Let us understand that. How it is simplified? Let me write that. See, the same continuation of that formula in the simplified form. That is why I'm naming it as AB. This is A. What happens if AB becomes 0? That is, A becomes 0, B becomes 0. Then you can take only xy or hxy or 2hxy, whatever. So A is equal to B is equal to 0. Then new origin. New origin is equal to, see here, h is remaining. This becomes 0. hf by minus h square. H is getting cancelled. Minus f by h. Here also, this becomes 0. And gh by minus h square minus g by h. You need not have to remember that separately, what I say. You need not have to remember that separately, because on the substitution you will get the same. Of course, I have not given you so far the shortcut. We will see the shortcut also, how to do that. Number B, h is equal to 0, then new horizon please. Is equal to h is equal to 0, the new horizon. This becomes 0, this becomes 0, this becomes 0, this becomes 0, minus bg by ab, bb getting cancelled, minus g by a, comma, minus f by. Simplified. That much a bigger formula is simplified to this form, minus g by a minus f by b. So these are the simplified form of this only. So accordingly, according to the problem given, you have to apply this. Now, the short form of doing this. Short form of doing this, please. Let me take this as f of x comma y. Let me take this as function of xy. Let me take this as function of xy. Then new horizon is got by solving dou f by dou x is equal to 0 and dou f by dou y is equal to 0. Dou f by dou x is equal to 0 and dou f by dou y equal to 0. Understand that? And if you want to understand this dou means partial derivative. If you know the derivative, then you will be knowing the partial derivative. Partial differentiation you will be getting further in your engineering, in your higher studies also. So partially differentiated. Partially differentiated with respect to x. That means you have to take only x as variable, rest all are constants. If you are partially differentiating with f with respect to x, then you have to take only x as variable, the rest all are constant. Similarly, if you are partially differentiating f with respect to y, then you have to take only y as variable and rest all are constant. That means if you want to differentiate this with respect to x, then you tell me what should it be. Then you tell me what should it be. That is, I'm writing that. Dou f by dou x, we are differentiating with respect to x, so x square derivative 2x, so that becomes 2ax plus 2hxy, x derivative 1 and y is constant, so 2hy remains, plus by square becomes a 0 because y is treated to be constant when you are partially differentiating with respect to x. This becomes 0 and 2gx, x derivative 1 plus 2g equal to 0 because 2f 0 and c also 0. Okay, now coming to with respect to y, please, with respect to y, ax square derivative becomes 0 and 2hxy becomes derivative becomes 2hx. 2hxy. Now with respect to y, y derivative is 1, 2hx remains. By square derivative 2by plus 2gx derivative becomes 0 totally. 2fy derivative becomes 2f equal to 0. Of course, these two can be taken common and it can be cancelled. So what are the equations finally you have got? What are the equations finally you have got? Ax plus hy plus g equal to 0. hx plus by plus f equal to 0. ax plus hy plus g equal to 0. hx plus by plus f equal to 0. If you remember the determinant what I taught you, it is nothing but the first two rows of it. It is nothing but the first two rows of it. What are the first two rows? A handsome guy has beautiful fiancée. A handsome guy has beautiful fiancée is nothing but these two equations. By solving these two equations only, you will get this new horizon, remember. By solving these two equations only, you will get this new horizon. So, this is what the short form of it. This is what the short form of it. If we take a problem, then you will better understand it. If you take a problem, then you will better understand it. So with regards to the shifting of origin, with regards to the shifting of origin, what are the points that are to be remembered and reviewed? What are the points that are to be remembered and reviewed? Original point is equal to new point plus new origin. Original point is equal to new point plus new origin. That is small x plus small y is equal to capital X plus x1 plus capital Y plus y1. Among these three, original point, new origin, among these three, if two are given, you can find out the third one. In these three, if two are given, you can find out the third one. Any two are given, you can find out the third one. This is what? The broad understanding. This should be a broad understanding. Original point is equal to new point plus new origin. And after that, if the point is shifted, I mean to say the origin is shifted, if the diagram I have erased here. If the origin is shifted to some other point, every point on the plane will be shifted or transformed. Then how the equation changes, how the equation f of x comma y is equal to 0 changes, it will be changed as f of x plus x1 comma y plus y1 is equal to 0. Is equal to 0. Now, this is the transformed equation. Now, what are the formulae related? And of course, there is a theorem for this. I'm not going to derive that. You may be getting that in your board level. Board level, that is a theorem. Big theorem is there. Then that's also simple. If you are interested, go through your board textbook. You will understand that. You will understand that. So the new origin. What is the important point to be remembered? You have to, if you want to remove xy term, that is very important thing. If you want to remove xy terms, then the new origin that is to be shifted. The new origin that is to be shifted is hf minus bg by ab minus h square gh minus af by ab minus h square. Chandra Reddy, good afternoon. After a long time, I hope you are all doing well. Now this is hf minus bg by ab minus h square gh minus af by ab minus h square is the new origin. Now, what happens if the equation is simplified, or if you got a simplified equation like a0 b0, then what happens? The new origin will be minus f by h minus g by h. And if h is equal to 0, then new origin will be minus g by a minus f by b. You can make use of it. If you don't want to remember all this, then what happens? Simply apply the short form, and of course you must be knowing the derivative, the basic derivatives only. What are the basic derivatives? X power n derivative. N into x power n minus 1. If you know the basic derivative, that is done. But only you have to remember, or you have to understand what is the partial derivative. Partial differentiation, I said, you don't have in your board level, but in some states it is there. In Tamil Nadu, the partial derivatives are there. In AP and Telangana, partial derivative not there. Even in Maharashtra also partial derivatives not there. Some board examinations also in 11th and 12th, they have partial derivatives. And most of the boards, they don't have partial derivatives. But these partial derivatives you will have in your engineering, no doubt in this. So, partially differentiated. In the name itself, partial derivative, no? Partially differentiated. What is that? F is partially differentiated with respect to x. F is partially differentiated with respect to y. So, what is the derivative of ax square? 2ax. What is the derivative of 2hxy? 2hy is a constant. 2hy is a constant. Derivative of x is 1. So, 2hy. And what is the derivative of by square? Totally constant. Its derivative is 0. 2gx. And x derivative 1, 2g remains. And these are zeros. So, that is the first equation. With respect to y, ax square totally constant, and hence its derivative becomes 0. And 2hx becomes constant, y derivative 1. So you get 2hx, by square, 2by, and 2gx derivative totally 0, 2f derivative 2f is equal to 0. These are the two equations. And by solving those two linear equations, you will get the same, I say. You will get the same. And how to remember that? I said, a handsome guy has beautiful fiancée. Third row is gone for cinema. That is a determinant we have taken. Delta we have taken. So the same. Okay, now this is about the shifting of origin. And after shifting of origin, we will have the rotation of axis. But before going to rotation of axis, let us first understand the problems that are related to this shifting of origin. Okay, so let me explain you. Let me take you to the problem part. Okay, now the problem part, please. The new coordinates of a point 4 comma 5, the new coordinates of a point 4 comma 5 when origin is shifted to the point 1 comma 2, when the origin is shifted to the point 1 comma 2. Very simple, please. Very simple. That is what is that? I said the formula related to it. What is that I explained is original point is equal to new point plus new origin. Original point is equal to new point plus new origin. What is the original point? The new coordinates of a point. This is nothing but the original point. 4 comma 5 is equal to, when the origin is shifted to the point 1 comma minus 2, new point is to be find out. New origin is given to be 1 comma minus 2, which implies new point is equal to 4 minus 1, 3, 5 plus 2, 7, 3 comma 7. Very simple. Very simple, please. Very simple. So, your answer must be 3 comma 7, please. This is your answer. Okay. I hope you understand that. 3 comma 7. Now, let's move on to the next problem. The coordinate axes are rotated through an angle 135 degrees. Okay, we have to come to it. That is, this comes under rotation of axis. We'll go to that. We'll go to the next. After working out, let me explain you the rotation, and then we will go through these two problems, 122 and 123. Now, 124 please. 124. Without changing the direction of coordinate axis, the origin is transferred to h comma k so that the linear terms in the equation are eliminated when the point hk is. It is direct question, please. Direct question. What is that you have to understand? without changing the direction of coordinate axis, origin is transferred to HK. That is, here you have to understand the new origin is nothing but HK. And so that the linear first degree, this is not 1 degree, we call it as first degree, terms in the equation are to be eliminated. Very simple, please. Very simple. Let me apply the short form what we have learned now. Okay. This is dou f by dou x equal to 0. Dou f by dou x equal to 0. You will get the answer within one step for this. See here. For this, we are writing dou f by dou x. Dou f by dou x equal to 0 implies x square derivative 2x, y square derivative 0, because we are differentiating with respect to x, please. And minus 4x derivative, minus 4, 6y 0, constant 0. So dou f by dou x equal to 0 implies that x is equal to 4 by 2. Similarly, dou f by dou y is equal to 0 implies y square derivative 2y, x square derivative 0, minus 4x derivative 0, 6y derivative 6 is equal to 0. 7 derivative obviously becomes 0. Y is equal to minus 3. So your answer is 2 minus 3. I hope you better understand that. Okay, Samay. Okay. Highlight with yellow, you're saying? Yes, I'll do that. Further, I'll do that. So dou f by dou x equal to 0. I'll do one thing, I'll scroll it so that you can see the question easily. Yeah, now you can see the question. Solution and the question. This is the answer. So dou f by dou x equal to 0 and dou f by dou y equal to 0 gives you 2x minus 4 equal to 0, x equal to 2, 2y plus 6 equal to 0, y is equal to minus 3. So 2 minus 3 is the answer. Okay? Now, let me move on to the next question. The point 4 comma 1. This question I am discussing. The point 4 comma 1 undergoes the following two successive transformations. Number 1, reflection about the line y is equal to x. Number 2, rotation through a distance 2 units along the positive x-axis. Rotation through a distance 2 units along the positive x-axis. Then the final coordinates of the point are. Of course, this involves the reflection of a point in a line y is equal to x. This involves the reflection of a point in a line. Of course, we can do that, no problem. I'll explain it. Let me say, this is y-axis, and this is x-axis, and a line is given which is y is equal to x. Y is equal to x is such a line on which x coordinate is equal to y coordinate. Y is equal to x is a line on which x coordinate is equal to y coordinate. Okay. Now, what is the point given? 4, 1. This is 4 units on x-axis and 1 unit on y-axis. Let me write that. This is the point. Some point here. 4, 1. Let me say this as P. Now it is reflected. Now it is reflected through this line. Reflection means you have to remember the mirror. When you see your face in the mirror, the distance of your face from the mirror is equal to the distance of the image inside the mirror. That means from the mirror to you and from the mirror inside the image, the distances are equal. So here, whenever any point is reflected in the line, remember, whenever any point is reflected in the line, y is equal to x. See this. Any point reflected in the line y is equal to x, then 4, 1 becomes 1, 4, please. If the point is AB, in y is equal to x, if it is reflected, the AB becomes BA. 4, 1 becomes 1, 4. It is always perpendicular because it is a reflection. That's right, Pratham. You said the reflected point is 1, 4, but again, rotation through a distance 2 units along the positive x-axis. It is rotated through 2 units along the positive x-axis. This is also to be understood. That means how many units it is moved forward. Why I am saying forward? Because it is positive x-axis. It is positive x-axis, please. Okay. Now This is moved through how many units, please, according to the question? 2 units. Moved 2 units. And hence, the final point, let me say this as P dash, becomes, how many units it is moved? 2 units in the positive direction. That is why 2 added. 1 plus 2 comma 4. So your answer is 1 plus 2 comma 4. So 3 comma 4 is the answer. I re-explain it. What is it? A 0.41. This is a 0.41 here. This is a 0.41 here. It is reflected in the line y is equal to x. The important point that is to be remembered by you is that whenever a point A comma B is reflected in the line y is equal to x, reflected in the line y is equal to x means you have to take y is equal to x as the mirror. If you see the image of a point A comma B in the mirror line y is equal to x, that becomes B comma A. Remember that. And of course, in the straight line topic, we will be having that. Reflection, image, that is a concept. Foot of the perpendicular, these are the concepts we are further learning in straight line. So 4 comma 1 point will be reflected as 1 comma 4. 4 comma 1 point is reflected as 1 comma 4 in the line y is equal to x. Now again, it is moved through a distance of 2 units towards positive x-axis. 2 units towards positive x-axis. That is why 2 units are added there. I am saying this as P dash, please, and this as P double dash. First stage that becomes P dash, second stage it becomes P double dash. Because it is moved 2 units towards positive x-axis, 1 plus 2 comma 4. So 3 comma 4 is the final answer for this one. Okay? Good afternoon, Roy Babu sir. So this is, you have to understand, when a point 4 comma 1 undergoes the following 2 successive transformations. Number 1, reflection about the line y is equal to x. Number 2, rotation through a distance 2 units along the positive x-axis. So the reflection of 4 1 in the line y is equal to x is 1 comma 4 because it is transformed through 2 units distance towards the positive x-axis. That is the reason why it becomes 1 plus 2 comma 4. So the answer is 3 comma 4. 3 comma 4. So this is about shifting of origin concept. This is about shifting of origin concept. Okay, now let us move on to rotation, please. Let us move on to rotation. In the rotation, you will have a very good derivation for that one. Generally, the derivation is not given by the teachers, but let me give you, for the better understanding and also the method, whatever we discuss here may be useful in the geometrical operations of other problems. So now I am dealing with rotation. Rotation of axis without shifting the origin, that is also important. Rotation of axis without shifting the origin. So it is easy in the shifting of origin, finding the relation is easy, but in the rotation, finding the relation is a little difficult, because you will understand that, because there are 3 items are there in shifting of horizon. Number 1, original point. Number 2, new point. Number 3, new horizon. Original point, new horizon, and we have got the relation between them. Original point is equal to new point plus new horizon. Original point is equal to new point plus new horizon. Yeah, that's right. Whenever you move towards x-axis, x coordinate changes. That's right. Now, let me explain you the rotation. Let me explain you the rotation piece. You have to understand this diagram carefully. Original x-axis, original y-axis. Now the axes are rotated through some angle theta, let me say. Capital X, capital Y. This is rotated through some angle theta. What are the properties we get in this derivation? Even though the final result is important, why I am deriving it, whatever the properties we apply here to derive this result are important, even in deriving some geometrical, even in applying some geometrical properties in other problems. That's the reason why I am deriving it. Very simple. And also you have to understand, whenever new axis, you have got x and y through rotation without shifting the horizon. Remember that, without shifting the horizon. Every point on the plane will also be changing. Every point on the plane will also be changing. How that point changes? Previously also we did the same. So now let me take a point here. P small x small y with respect to original axis, the same point with respect to new axis is capital X capital Y. So what is that we are taking? We have located a particular point P. We have located a particular point P, which is small x small y with respect to small x small y with respect to original axis, capital X capital Y with respect to new axis, Now we want to find out the relation. In the previous case, original point, new horizon. In this case, original point, new point, and the angle of rotation. This makes the difference. That means you have to find out the angle between the it is theta, and hence you have to find out the relation between these three. Anyway, there 3 quantities, here also 3 quantities. Okay, now let me do this. Let me drop a perpendicular from P onto the new axis, onto the original axis. Perpendicular. Why always perpendicular? Because the distances can be located. This distance is small x here, and this distance, the total distance is capital Y there. Okay. Now, let me drop another perpendicular onto the new axis from P. This is a perpendicular. Okay, let me name this PQ, R, and let me drop another perpendicular. Yes, this is also 90. Now, whatever the next concept I am teaching you or I am telling you must be carefully understood by you. That is, angle between two lines. Is equal to angle between their perpendiculars. These are the two lines and this is the angle between them. And if you draw perpendiculars to these two lines, The angle between these two perpendiculars is equal to the angle between the lines. So what is what you have to understand? Angle between two lines is equal to angle between their perpendiculars. This is what you have to understand. Even you will get the same concept in three-dimensional geometry also. Even you will get the same concept in three-dimensional geometry also. That is, generally the angle is defined between the lines only. The angle is defined between the lines only. Then whatever the other curves are there, whatever the planes are there in the room in which you are sitting, if two planes are there, how to find out the angle between the planes? How to find out the angle between the curves? Then they have to be converted finally to the lines only. They have to be finally converted to the lines only, whatever. So in three-dimensional geometry, what we say, angle between two planes. This is one plane, that's another plane. Angle between the two planes is nothing but angle between their normals. That is one plane, this is a perpendicular to it or normal to it. This is one plane, this is a perpendicular or normal to it. So the angle between the planes is nothing but the angle between the lines. Angle between their normals. Angle between their normals. Same is the case here. Same is the case here. Follow this. Now, this is x-axis. Original, it is its perpendicular. PQ is its perpendicular. This is new x-axis. It is its perpendicular. PR. This is original x-axis, new x-axis. Angle between them is theta. It is its perpendicular and it is its perpendicular. So, angle between these two is nothing but angle between these two. This is what you have to understand. So, angle between any two lines is equal to angle between their perpendiculars. Angle between their perpendiculars. Now, our interest is to find out the relation between original coordinates, new coordinates and theta. Okay. Now, let me draw another perpendicular from R onto original x-axis, PQ, R, ST, let me say. Now, I am interested in OQ. Follow this carefully, please. OQ. OQ is nothing but OT minus QT. Samagar, is it clear? The board is clear. Just respond. Just respond. Whether you are able to see the board or not. OT is equal, OQ is equal to OT minus QT. This is OT, totally. OT minus QT. This is QT. Let me write OT now. Let me write OT. See, OT, if you take, it is adjacent side. I'm talking about in triangle OTR. In triangle OTR, I'm interested in OT, which is adjacent side. Cos theta is equal to this is OT divided by, and you understand this OR is nothing but capital X, please. It is on new axis. It is on new axis, capital X, new axis. Just understand that, please. Cos theta is OT by X. And what is sin theta? Let us write this and keep it as it is. Sin theta is nothing but RT divided by X. Okay? RT divided by X. You have to understand that, please. I think it's clear? Okay. Now let us substitute that. Let us substitute that. This is the relation you have to remember with respect to the trigonometry. Now, let us substitute that. OQ is nothing but small x is equal to OT is nothing but x cos theta minus Q2, QT. This is QT, which is QT, this one is QT, is nothing but SR. QT is nothing but SR. This is SR, please. In triangle PSR, what is sine theta? SR divided by. Understand, this is nothing but the height, please, height, which is nothing but capital Y. Capital Y. Understand that. So SR divided by capital Y, and cos theta is equal to, cos theta, please, cos theta is nothing but PS divided by capital Y. These are to be utilized further. Now x cos theta minus SR. What is SR here? Y sin theta. So you have got small x value. You got small x there. We have to find out now small y. Small y. Small y is nothing but PQ. PQ is equal to, this one please, PQ is equal to PS plus SQ. What is PQ? Is small y. This is the height of this point. Height of this point is nothing but small y with respect to original axis. With respect to original axis. Is equal to PS plus SQ. SQ is again RT. Now which implies y is equal to, what is PS here? What is PS? PS is nothing but y cos theta. What is RT, please? RT from this one. RT is x sin theta. You got small x, you got small y in terms of capital X, capital Y, and theta. This is a relation. This is a relation we have got with respect to the original and the new axis and the rotation of angle of rotation theta. Now, similarly, this is a relation from original to new. Original to new. And new to original also can be found out similarly. New to original also can be found out similarly. But because you have understand the basics of it, let me give you now the table to remember this easily. Table to remember this easily. That is small x, small y, capital X, capital Y, what is small x, small y? Original coordinates. What are capital X, capital Y? New coordinates. This is original. This is new. Simple. It is simple to remember. Here, cos theta minus sin theta. Sin theta, cos. Please understand that properly. Please understand that properly. I'll show you how to write this. Small x is equal to, whenever you are writing the old coordinates or original coordinates, whenever you are writing the original coordinates, then horizontal multiplication, this one. Whenever you are getting the new coordinates, vertical multiplication. Okay? Small x is x cos theta minus y sin theta. Small x is x cos theta minus y sin theta. Small y is x sin theta plus y cos theta. small y is x sine theta plus y cos theta. If you want capital X, x cos theta plus y sine theta. Capital X cos theta plus y sine theta. Capital Y, minus x sine theta plus y cos. This is to be remembered. This is to be remembered in rotation of axis, please. This is to be remembered in rotation of axis. In rotation of axis, that is the table is to be remembered. Okay. Now, you must get this down. Sir, we have already shifted the origin and we have learned the relation between them, and there we have taken a formula also to remove the first degree terms x and y. What should be the new origin? What should be the new origin? hf minus bg by ab minus h square, gh minus a by ab minus h square for a second degree non-homogeneous equation to remove the first degree terms x and y. That is there. And the short form also I gave you, it is dou f by dou x equal to 0, comma dou f by dou y equal to 0. You have to solve those two to get the new origin. Then, what is that is to be done here in this case for theta? The most general operation what we do in the rotation of axis is that we eliminate xy term. There x and y terms. Here only xy term. What is an xy term? X square plus 2hxy. 2hxy. That xy term is to be removed. To remove the xy term, what is the rotation that is to be made? To remove the xy term, what is the rotation that is to be made to the axis is our learning here. Our further learning is that. Okay. Here, to get that formula, a trigonometric simplification is involved. To get that formula, a trigonometric simplification is involved. What is that trigonometric formula? And what I do, I'll show you that derivation because it is comfortable, and simultaneously we'll be learning the trigonometric simplification also. Okay? Now, what is that? Let me tell you the theorem related to it. The angle to which the axes are to be rotated to remove the xy term in this case. Previously, to remove x comma y terms in the second degree non-homogeneous equation, we have rotated the axis, or we have shifted the origin. Sorry, not rotated. We have shifted the origin to a new origin, which is hf minus bg by ab minus h square, gh minus af by ab minus h square. Similarly, here, what is angle? What is angle that is to be rotated? What is angle that is to be rotated to remove xy term? That's what we are learning now. Now, this is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now, we are converting this. I am writing direct step so that you will understand this. We are rotating to some angle theta to remove this term. Finally, this term is to be removed after the rotation. Xy term is to be removed. So for that, what is the value of small x? X cos theta minus y sin theta. What is the value of small y? X sin theta plus y cos theta. Let me do that. Shift the origin. No, rotate the axis. Through theta. Therefore, transformed equation is A into, come on, tell me that. Small x in place of small x. X cos theta minus y sin theta whole square plus 2h into x cos theta minus y sin theta into x sin theta plus y cos theta. This one plus b into y square, y square. This is y. X sin theta plus y cos theta whole square plus 2g into plus 2g into something plus 2f into something, we don't need it, plus c is equal to 0 because we need only the xy term to be removed. So you have to collect only xy terms. You have to collect only xy terms. So we are collecting xy terms to remove xy term. Important please. Coefficient of xy is equal to 0. Coefficient of xy is equal to 0. Very important please. From this only we will get the result. Coefficient of xy is equal to 0. Just go through that please. Just go through that. What is that I am doing? We have to remove xy term. To remove xy term, wherever xy term is there, we will take its coefficient and we will equate it to 0. We will take its coefficient and we will equate it to 0. Okay. So, let us see that. Let us see that. Coefficient of xy please. If you expand this, a minus b whole square, a square minus 2ab plus b square. Here you will get a into minus 2a into minus 2 cos theta sin theta. Let's see this. XY coefficient is to be taken. Don't forget, XY coefficient is to be taken because it is to be equated to 0. What is the coefficient then? Minus 2 sin theta cos theta. That's what I wrote. A is already there. Coming to this, plus 2h into plus 2h into this is xy. xy here, cos theta into cos theta, cos square theta, sin theta into sin theta, minus sin square theta, plus b into this one, 2xy sin theta cos theta, nothing but 2 sin theta cos theta, must be equal to 0. That's it. That's it, please. So, take b minus a by making it as sin 2 theta. And this is 2h cos 2 theta equal to 0. Now, sin 2 theta into a minus b is equal to 2h cos 2 theta. I shifted this term to LHS or RHL, whatever. The sign will be sent, the sign is sent inside. Tan 2 theta is equal to 2h by a minus b. 2 theta is equal to tan inverse 2h by a minus b. Theta is equal to half tan inverse 2h by a minus b is equal to angle of rotation. To remove xy term, this is important. So what is the formula to be remembered, please? What is the formula to be remembered? You have to remember half tan inverse 2h by a minus b. Half tan inverse 2h by a minus b. This one, please. So in the first case, we removed x term and y term separately by shifting the origin, and thereby we have got the new origin to be hf minus bg by ab minus h square gh minus a by ab minus h square. There also the derivation is very much similar to this. Very much similar to this. I did not derive that because you have the short form for doing that. What is the short form? Dou f by dou x equal to 0, dou f by dou y equal to 0. Similarly, in the rotation we have to eliminate which term? Xy term. We have to eliminate which term? Xy term. So to remove xy term, what is the angle of rotation that is to be made? Angle of rotation that is to be made, we don't know that. Let it be theta. Let it be theta. That theta we have taken from the table by taking theta. We know that small x is x cos theta minus y sin theta, and small y is x sin theta plus y cos theta. We replace them, and rest all the terms we have written as it is because we don't want them. We want only coefficient of xy term. That is why to remove xy term, coefficient of xy is equal to 0. Where do you get coefficient of xy? Here. Minus 2 cos theta sin theta into a. Here also you will get xy term. Here also you will get xy term. These are equated to 0, and thereby you got theta is equal to half tan inverse 2h by a minus b. Half tan inverse 2h by a minus b. Whenever a minus b becomes 0, this becomes tan inverse infinity. It's nothing but 90. 90 by 2 is 45. Theta is 45 degrees. Like this it is. Now, this is about the rotation, please. This is about the rotation. Now, what are the concepts that are concentrated more? What are the concepts that are concentrated more in the previous JEE or previous engineering entrance examination questions are this. See, what is that I said? In the shifting of origin, I said every point on the plane is shifted, every point on the plane is changed, and thereby every equation is transformed. Then you must get this down. By shifting the origin, what is that? Don't change. What is that will not be changing? What is that will not be changing is the areas will not change, the distances will not change, the slope will not change. All these will be remaining same in shifting of origin. In shifting of origin, all these will remain same in shifting of origin. Okay. So, whenever the slope of a line is taken and the origin is shifted to some other point x1, y1, whatever the slope of the line is there with respect to original axis, the same slope remains with respect to new axis also. Similarly, areas, that is a fixed quantity. No, that's a constant quantity. That won't change. Distance won't change. Volumes won't change. Volume means it comes under 3-dimensional. The same concept will be extended to 3-dimensional. Not, of course, this one. According to our syllabus, only 2-dimensional rotation is there. 3-dimensional rotation means you will have all this in your engineering. That is evolution you will have. That is, evolution is like this. This is a square. Sorry, this is a rectangle. If this rectangle is rotated from the breadth side, if the rectangular sheet is rotated from the breadth side and it takes a cone, or it takes a cylinder, it becomes a cylinder. Then what is the radius of the cylinder, what is the height of the cylinder, and so on and so forth. This is 3-dimensional. You'll have 3-dimensional, all these you will have in your engineering. But here, as far as our syllabus is concerned, we will be fixing up one dimension, and we'll be discussing about the remaining 2 dimensions. In 3-dimensional geometry also, you will get the rotation like that. So, in the rotation of axis, very important, you have got good number of previous questions in the previous engineering entrance examinations with related to this property. What is that property? in the rotation of axis, what is a property or what is a quantity that won't change is the perpendicular distance from the horizon to the line. The perpendicular distance from the horizon to the line will never change. Let me show you that. See. See, what I'm doing, I'm taking up the original axis, and this is the line, this is the horizon, and it is the perpendicular distance OP from the horizon to the line. The perpendicular distance is OP. Now the axes are rotated through some angle. I'm trying with new color, other color blue. It's not that much clear. Now, this is rotated through some angle theta. This is new axis. This is also rotated through some angle theta, obviously. Then what is happening? This line, whatever the line is there, it will also be rotated. When the axes are rotated, line will also be rotated. How much it will be rotated? See here, just like this. It will rotate like this. It will rotate. This will go here. Let me say like this. This will go here. Let me say here. Then this is a new line. This is a new line, please. What is the property I taught you, Whatever the perpendicular distance is there, this will remain the same. Somewhere it will be. It is Q, let me say. OP is equal to OQ. Very important property, please. Very important property. You can check with the previous questions. You have the application of this in the previous questions. What is the property here? I repeat. The perpendicular distance from the horizon to a line remains the same even if the axes are rotated through some angle theta. So the perpendicular distance from the horizon to a line with respect to the original axis and with respect to the new axis after the rotation theta or the rotation of angle theta remains the same. This is an important property to be remembered. Okay, this is about the shifting of origin and then rotation of axis. Now let us move on to the questions part of it. Question number 122. Question number 122, please. the coordinate axis are rotated through an angle 135 degrees. That is theta 135. If the coordinates of a point P in the new system are known to be 4 minus 3, then the coordinates of P in the original system are, just to see how the question changed here, capital X, capital Y given. So that is the reason why I've been telling you in the coordinate geometry, understanding the given data is very important. Understanding the given data is very important, please. Capital X, capital Y given. What is capital X, capital Y given? 4 minus 3. And what is that to be find out? Small x, small y is to be find out. Can you try and tell me the answer? I'll show you the formula also. And you work out, tell me please. Let me check how many of you follow this. Small x, small y. Capital X, capital Y. This is cos theta minus sin theta. Sin theta, cos theta. We need new to original now. New to original. Check it out, please. Original is needed here. Small x is needed. Can you try and tell me? Small x is equal to capital X cos theta minus capital Y sin theta. Small y is equal to capital X sin theta plus capital Y cos theta. Please try. I'm expecting the answer from you because everything is data is written, formula is written, everything is written there. Answer D. Samegar answered this. Answer D. Arun, are you trying it? Small x is equal to, what is capital X? 4 cos 135. Cos 135 is minus 1 by root 2 plus capital Y is minus 3 sin theta sin 135 1 by root 2. So your x is minus 4 by root 2 minus 3 by root 2 minus 7 by root 2. This becomes plus. Okay, that's minus of no, this is minus, both are correct one. The answer is not seen. That's why I'm saying answer is not seen. Minus of, okay, that is minus of minus 3. This becomes plus. Correct. So this becomes minus 1. And y is 4 into 1 by root 2 plus minus 3 into cos theta minus 1 by root 7 by root. So that D is the correct answer. D is the correct answer. Okay, let's move on to the next question. Eliminating this. If the axis be rotated through an angle 60 degrees in the clockwise direction, the point 42 in the new system was formerly. Let's understand the question. It is given that it is rotated in the clockwise direction. Clockwise direction is always to be taken negative. 42 in the new system. Don't forget that new system point is given here. Formerly means old point or original point. So, according to the data given, what is that to be understood? Your theta is in the anti-clockwise direction. So, your theta is minus 60 degrees. Okay. And your capital X, capital Y is 42. You have to find out small x is smaller. You have to find out small x is smaller. Only the twist in the question is clockwise is to be recognized or remembered as minus 60 degrees. You should not take it as directly 60. And rest all same as the previous problem. The rest all same as the previous problem. Yes, please. I want the answer. I want the answer for this, which is very much similar problem. Similar problem, please. Some answer given to be B there. So small x is x cos theta, cos of minus 60, minus y sin theta. So it is nothing but 2 root 2 minus root 3. X cos theta plus y sin theta. X cos theta minus y sin theta, this becomes plus. Two root 2 plus root 3. Option is not there. Samega, please check the answer once. Check the answer. Small x is equal to x cos theta. X cos of minus 60, 1 by root 2. Sorry, 1 by, you're right. So it is 2. Minus y sin. So 2 plus root 3 and y is equal to x sin theta plus y cos theta. Y cos theta. One by 2 into 1 by 2. So 1 plus 2. So try straight question, please. Straight question. 1 minus 2 root. So B is the answer. Yes, you are right, sir. I wrote wrong. Cos 60, 1 by 2, I wrote 1 by root. That's correct. So this is answer B. Straight application. Now let's go to the next one. See this example 21, please. Example 21. The point 23 undergoes the following 3 transformations successively. Reflection about the line y is equal to x. And transformation through a distance 2 units along the positive direction of y-axis. Rotation through an angle 45 degrees. Rotation through an angle 45 degrees. in the anti-clockwise direction. That means theta positive only, anti-clockwise direction. Then the final coordinates of the point are, as we have already understood that it is when the point is 2, 3 is reflected in y is equal to x, it becomes 3, 2. I need not have to tell you that because we discussed this already. 2, 3 becomes 3, 2. It is transformed to a distance 2 units along the positive direction of y-axis. That means it becomes 3 comma 2 plus 2. That is 3 comma 4. Now rotation of an angle 45 degrees about the origin in the anti-clockwise direction. Then you have to find out the final coordinates of the point. That is, here it is small x small y. And theta is how much? 45 degrees. You have to find out capital X, capital Y. Yes, data is given. Data is given. Arun is not responding. Arun, respond. Pratham is there online. Pratham, are there online? Arun and Pratham. Check the data given. Now substitute and get the answer. Everything is done here. Do you understand all this, Arun? Small x to small y, capital X, capital Y, cos theta minus sin theta, cos theta. Compared to the previous problems, here you have to find out capital X, capital Y. Small x, small y is given. Theta 45 degrees. Theta 45 degrees. So capital X is, small x is nothing but 3. 3 cos 45. 3 into 1 by root 2. Plus y. That is here minus sin theta. Minus 4 into 1 by root 2. And capital Y is minus x sin theta minus 3 into 1 by root 2 plus 4 into 1 by root 2. So what should be our final answer? It is minus 1 by root 2. It is 1 by root 2. 7 by root 2 given there. Yeah. Minus x cos theta plus y sin theta. This is plus of it. This is plus of it, correct. Minus 1 by root 2. Let me do it again. Got the answer, Samay garu? In the anti-clockwise direction, rotation through an angle 45 degrees about the origin in the anti-clockwise direction, then the final coordinates of the points are. Yeah. This is final coordinates means we have to find out new coordinates only. As I said, small x is 3 cos 45, 3 by root 2. Small y is 4 by root 2. Capital Y is minus 3 by root 2 plus 4 by root 2. So your perfect answer must be 7 by root 2 comma 1 by root 2. But what he did now, he has taken this as capital X capital Y, which I feel it is wrong. Because you have to find out the final coordinates. Final coordinates. Final coordinates means new coordinates. I think it should be none of this. It should be none of this. He has taken small x small y as capital X capital Y. That is new. He has taken the new coordinates. If you take this as new coordinates, you will get the answer. But these are the original coordinates. Okay? Where you are saying, Arun, minus 3 will not come. Okay, remove it. Just check. I think even though the answer is given to be minus 1 by root 2, 7 by root 2 here, I don't think that is correct. D is the answer. But you also check it out once. Because I have taken after the second transformation, I have taken this as the original point, but he has taken it as new point. But asking for the final coordinates here. Final coordinates means there must be new coordinates only, according to me. There must be new coordinates only. Anyway, we'll see that. We'll see that. Next one. Example 22, please. Reflecting the point 2, 1. Reflecting the point 2, 1. about y-axis. The coordinates axes are rotated at 45 degrees angle in negative direction without shifting the origin. Then the new coordinates of the point are. Then we will, now here we will understand whether his answer is correct or our answer is correct. Because here reflecting the point 2 minus 1 about y-axis is saying, if this is y-axis, this is x-axis, what is the point given there? 2 minus 1. So if you mark 2 minus 1, this is 2 minus 1 somewhere here, and it is reflected in y-axis. When it is reflected in y-axis, this P comes to, P will be reflected in the third quadrant, which is nothing but minus 2 minus 1. Which is nothing but minus 2 minus 1, please. Now, what I am doing, after the reflection, this is a reflection, please. This is a reflection. I'll change the color. This is a reflection. Okay. Now, that axes are rotated through an angle 45 degrees about the origin in the anti-clockwise direction, that is positive direction only. So you take theta 45 degrees. Take this as small x small y. Then whether ours is correct or his is correct, he has taken in the previous case it has capital X capital Y. Now you have to find out capital X, capital Y. Come on, find out please. Capital X is small x cos theta minus 2 by root 2 plus small y sin theta. Small y is minus 1. So minus 1 by root 2. So it should be minus 3 by root 2. This one. B. Capital Y minus x sin theta plus y cos theta. Capital Y is minus x sin theta plus y cos theta. This also you have got to be minus 3 by root 2. Just work out please. Here also I got none of this. But here his answer is minus 1 by root 2 minus 3 by root 2. What is that he has taken? Minus 2 cos 45. This is okay. Minus 1 sine of minus 4. It is given to a negative direction. Clearly it is given to a negative direction, please. Please. I have taken plus 45. This is minus 45, please. Minus 45. So small x is equal to x cos minus 45 plus y sine of minus 45 plus 1 by root. This will become plus 1 by root. And here minus x sine 45 minus x sine 45 plus 2 by root. Minus x sine of minus 5, which becomes plus 2 by root. plus y cos 45. That is 1 by root 2. So the answer is minus 1 by root 2 minus 3 by root 2. Minus 2 sine of minus 1. Three minus there. 3 minus, you will get minus 2. So final answer, you will get it as minus 1 by root 2 minus 3 by root 2. So option A please, option A. Hi Karthik. Where from are you, Karthik? So that's what it is. Now, this is about change of axis, in which we have seen shifting of origin and rotation of axis. In the rotation of axis, the table is to be remembered. Further also, you will be getting the same in the questions. While simplifying, you must take care of anti-clockwise direction, clockwise direction. When anti-clockwise direction is given, it is positive direction. When clockwise direction is given, it is negative direction. That means you have to put a minus before theta for clockwise direction. Okay, now that's about the change of axis. Now, the next part, what we are going to deal with is a straight line. We're going to deal with a straight line, and in fact, in the JEE syllabus, or whatever the engineering examination is there, engineering entrance examination there, the coordinate geometry starts with straight line only. But without all these basics, you cannot learn straight line or pair of straight lines or circle, parabola, ellipse and hyperbola. All these fundamentals and the basics must be there to learn them perfectly. That is why I taught you all this. Now next we are going to start, in the next session we are going to start straight line, and I have divided straight line into almost 15 to 20 sub-concepts. 15 to 20 sub-concepts. What I mean to say, I will not be directly introducing the entire theory, and I will not be going to directly to the problems. I have divided the entire straight line topic into some 15 to 20 sub-concepts, subtopics, and we will learn one subtopic and then related problems. We will learn second subtopic and the related problems. We will learn third subtopic and the related problem, or sometimes maybe first and second subtopic and then the related problems. Like that, we will be learning straight line, and finally after the completion of all the concept, we will be going through the heterogeneous problems. What I mean to say by heterogeneous, that the questions that are related to more than one concept, okay, that we will start in the next session, and that will be the straight line in the next class. Tomorrow I'll be scheduling that. I'll make you understand that in a better way. Namaste.